In this segment of our CompTIA SecurityX certification course, we focus on security architecture, and particularly on the importance of implementing security in the early stages of the system's lifecycle. Incorporating security measures from the beginning helps in identifying potential vulnerabilities and addressing them promptly. This proactive approach not only reduces the risk of security breaches, but also contributes to cost efficiency by resolving issues early in the development process. In this slide, we are focusing on the overview of integrating security in the early stages of the system's lifecycle. There are two main points of importance that we need to consider. First, early integration of security measures significantly reduces vulnerabilities. By addressing potential security concerns at the onset, we can prevent them from becoming larger issues down the line. This proactive approach ultimately contributes to a more robust and secure system. Second, addressing security issues early in the development process is cost-effective. Identifying and mitigating vulnerabilities during the initial stages can help avoid the higher costs associated with fixing these issues after the system is fully developed or deployed. Additionally, there are key concepts that are crucial to understanding how to implement security early on. Software assurance ensures that the software behaves as expected and is free from vulnerabilities. Meanwhile, adopting effective testing methodologies allows us to thoroughly assess and validate the security of the system from the beginning. By focusing on these aspects, we set a strong foundation for building secure and reliable systems. In this slide, we delve into the concept of software assurance. At its core, software assurance is about ensuring that software performs its intended functions while remaining free of vulnerabilities. The overarching goals here include reliability, security, and maintainability. To achieve these goals, various techniques such as code reviews and the use of automated testing tools are employed. Code reviews involve a thorough examination of the software's source code by developers other than the original author, providing a fresh perspective to identify potential issues. Automated testing tools, on the other hand, use predefined rules and algorithms to test the software, offering a scalable and efficient way to detect flaws. Both of these techniques are essential in building robust, secure, and maintainable software. Static Application Security Testing, or SAST, is a technique used to analyze source code for vulnerabilities without actually executing the program. This allows for the identification of security flaws early in the development process, contributing to the overall security and reliability of the software. Some common tools used for SAST include SonarQube and checkmarks. For instance, SonarQube can be executed using a command like the one shown here: sonar scanner -dsonar.project key equals project down.sources equals -dsonar.host.url h/localhost 9000. This command helps to scan the project's source code specified by the sonar.project key and sonar.sources parameters, connecting to the specified SonarQube host URL. The primary benefit of SAST is the early detection of security flaws. By identifying issues during the initial stages of development, SAST helps in mitigating risks before they evolve into more severe problems during runtime, ensuring a more secure and robust software product. Dynamic Application Security Testing, or DAST, involves testing a running application to identify vulnerabilities. Unlike static analysis, which examines code without executing it, DAST interacts with the live application, providing insights into runtime issues that might not be apparent from static code analysis alone. Two common tools for DAST are OWASP-Zap and Burp Suite. For instance, you can use OWASP-Zap to perform an automated scan with the command zap_baseline.py -rep.html-t HTTP's localhost 8080. This command conducts a baseline scan of the application running on localhost 8080 and outputs the results to a report file named rep.html. The primary benefit of DAST is its ability to identify runtime issues, such as those related to configuration, authentication, and session management, that static analysis might miss. This makes DAST an essential part of a comprehensive security testing strategy, complementing static analysis by providing a broader perspective on the security posture of your application.
Interactive Application Security Testing, or IAST, takes a hybrid approach by combining elements from both Static Application Security Testing, SAST, and Dynamic Application Security Testing, DAST. IAST provides real-time analysis, which allows for the detection of vulnerabilities as the application runs. Some common tools used in IAST are Veracode and Contrast Security. One of the key benefits of IAST is its ability to detect issues in real time, offering contextual insights that traditional testing methods may miss. This integration of multiple testing approaches offers a more comprehensive security analysis, enhancing the overall security posture of your application.
Runtime application self-protection, or RASP, is a security mechanism where security is embedded directly into the application. This allows the application to self-protect and respond to threats immediately during execution. One of the key advantages of RASP is its ability to provide real-time application protection, which means threats can be mitigated as they occur, rather than after the fact. For example, RASP often uses instrumentation-based monitoring to actively observe and mitigate threats at runtime. By integrating RASP, you enhance your application's ability to defend itself, providing a more dynamic and responsive security posture.
In this slide, we will discuss vulnerability analysis. The primary purpose of vulnerability analysis is to identify and classify security flaws within an application. This process is integral to maintaining the security and integrity of software systems. Common techniques used for vulnerability analysis include penetration testing and automated scanners. Penetration testing involves simulating attacks on the software to identify weaknesses that could be exploited. Automated scanners, on the other hand, quickly scan the application to find known vulnerabilities without the need for manual intervention. Some example tools used in vulnerability analysis are Nessus and OpenVAS. Nessus is a widely used vulnerability scanner that can identify various security issues in different types of systems. OpenVAS, another comprehensive scanning tool, helps in detecting vulnerabilities and provides various functionalities to mitigate them. Vulnerability analysis is a crucial step in the application security lifecycle, helping developers and security teams address potential security issues before they can be exploited by malicious actors.
Now, let's explore software composition analysis, SCA. SCA is a technique for analyzing the components and libraries used within a software application to identify any known vulnerabilities they might contain. This type of analysis ensures that you are aware of potential risks that stem from third-party dependencies. Some common tools used for software composition analysis include Black Duck and SNCC. These tools help you automatically scan your dependencies and alert you to any known issues. One major benefit of SCA is that it can identify vulnerabilities in the dependencies which might otherwise go unnoticed. For instance, using the SNCC tool, you can run a command like snike test all projects to scan all projects for vulnerabilities in their dependencies. By incorporating SCA into your security practices, you add an extra layer of protection and awareness, ensuring your application is secure from vulnerabilities in third-party components.
On this slide, we are discussing the Software Bill of Materials, or SBoM. An SBoM is essentially a comprehensive list of components that make up a piece of software. This list is crucial for maintaining transparency in the dependencies you're using, especially third-party components. By having an SBoM, it becomes significantly easier to manage vulnerabilities, as you can quickly identify and assess the risks associated with each component. An SBoM is typically presented in a format like CSV or JSON, where all libraries and their respective versions are listed. This structured format allows for efficient parsing and analysis, simplifying the tracking and management of your software's components. As we move forward, understanding and utilizing an SBoM can be a vital step in maintaining the security and reliability of your software products.
Formal methods are mathematical approaches used to verify the correctness and safety of software. These techniques ensure a high level of assurance in software reliability, making them a valuable tool in the software development process. Some of the main techniques in formal methods include model checking and theorem proving. Model checking involves systematically exploring the states of a system to verify properties such as correctness and safety. Theorem proving, on the other hand, uses mathematical logic to prove that a system adheres to its specifications. However, employing formal methods comes with its own set of challenges. These techniques can be complex and resource-intensive, requiring specialized knowledge and substantial computational power. Despite these challenges, the benefits of using formal methods, such as achieving high assurance of software reliability, make them an important consideration in critical systems development.
In conclusion, let's recap some of the key points we've discussed. First, emphasizing security in the early stages of the software development lifecycle is crucial. By addressing security concerns early, you can prevent costly fixes and mitigate risks before they compound. Second, it's important to utilize a range of security tools and testing methods for comprehensive security coverage. This includes static application security testing, SAST, dynamic application security testing, interactive application security testing, IAST, and runtime application self-protection, RASP. Each of these tools plays a unique role in identifying vulnerabilities and providing layers of defense. Lastly, software assurance is paramount. This involves a combination of both manual and automated techniques to verify and validate your software's security and reliability. By integrating these practices, you ensure a robust and trustworthy application. In this final part, we will discuss the next steps you should consider for enhancing your software security practices. First, hands-on testing with the tools mentioned, such as SAST, DAST, IAST, and RASP, will give you practical experience and insights into identifying and mitigating vulnerabilities. Regular practice with these tools is essential for mastering their use. Additionally, for further reading, I highly recommend the OWASP Testing Guide and the NIST Secure Software Development Framework, SSDF. These resources provide comprehensive guidelines and best practices that are invaluable for anyone serious about software security. Finally, if you're looking to formalize your knowledge and skills, consider continuing your studies for the SecurityX certification. This certification will not only validate your expertise, but also enhance your credibility as a security professional. By following these steps, you will be well equipped to tackle security challenges effectively and stay ahead in your career.
Thank you for taking the time to follow along with this course. Your feedback is incredibly valuable, so if you enjoyed the content, please leave a like and comment below with your thoughts or any questions you might have. Don't forget to subscribe to the channel for more insightful content and share this course with your friends and colleagues who might also find it useful. Your engagement helps us to improve and provide you with the best learning experience possible. In this slide, we have listed some valuable references that can provide further insights and resources to deepen your understanding. The first reference is OWASP, which stands for the Open Web Application Security Project. It is an excellent resource for web security practices and offers various tools and documentation. Next, we have NIST, the National Institute of Standards and Technology, which provides comprehensive guidelines and standards on cybersecurity and other technologies. Also listed is SNIKE, a company specializing in developer-first security solutions. SNIKE offers tools for identifying and fixing vulnerabilities in your code, dependencies, containers, and infrastructure. Finally, Veracode is mentioned. Veracode provides application security solutions that help developers and security teams find and remediate vulnerabilities throughout the software development lifecycle. These references are highly recommended for anyone looking to enhance their security practices and knowledge.